All right, so this is lesson 0.3.1, absolute value and adding and subtracting integers. Today, in part A, we're going to focus on the absolute value and the adding of integers and just understanding integers in general. So that's going to be these first three objectives. That's what we want to accomplish today. So let's take a look at number 1, to understand and use integers. Integers are a number without a decimal or fraction part. Okay, no decimal part, no fraction part. And integers can be used to model or represent real-world situations. Some example situations. The height of a mountain. So I'm like, mountain. From here to here, maybe that's 1,700 and, well, that's not really a mountain. 17,000, that's maybe larger than Everest, but 271 feet. In this case, since the height is up from my 0, that would be a positive integer. I could also have depth below sea level. So here's my ocean, and maybe I have a whale that is negative 374 feet below sea level, where sea level is my 0. I could also represent profits or gains or refunds. I ordered a shirt, turned it back into Amazon, and I got a refund of $32. That means my money went up by $32. I have gained $32. Or I sold some stuff and made a profit of $32. But if I go to the store and I spend $12, that's going to be negative to my account. Or I lose $12 because I bought something high and sold low. So I lost money. Then those are negative numbers. And then we can represent integers primarily by counters or on the number line. So by counters, I will use these red and green circles, or I'll use red for red for negative, and green for positive, and you'll see these little kind of counters. I understand I don't expect you to bring a bunch of colored pens and paper pencils and all that to class. So typically what I'll do to represent with counters is I will do a negative, will just be a minus sign, and I'll do positives with circles. That's the fastest way that I found. So if I wanted to represent negative 3, that would be 3 negative signs as counters, handwritten. And if I wanted to represent positive 5, then I'd use 5 circles. Okay. I don't use plus signs, and we'll see why when we get toward the end of our notes. Okay, so we don't want to use pluses and minuses necessarily. I use negatives and positive circles. Okay, and then we can also represent these on number lines. To me, the vertical number line is the easiest. Oops, make that a little smaller. Because when we go up on the vertical number line, we get more positive, and that makes sense mentally. And when I go down, I get more negative. So down is negative, up is positive. More frequently, we'll use a horizontal number line, where 0 is in the middle and positive is to the right. 3, 6, 5. Positive to the right and negative to the left. Okay, so one way I help myself remember it is it's right to be positive, positives to the right. Okay, so I'm just not sure. All right, so we're going to pause here and do formative exercises. I'll get the numbers for you in just a second. We are going to pick up with absolute value, still in our 0.3.1 lesson. Absolute value is the distance from 0. That's all. So if I have a number line, and this is 0, if I'm at 1, 2, 3, my distance from 0 is 3. If I am using, let's see here, a point here, 1, 2, 3, -4, my distance from 0 is 1, 2, 3, 4. Just how far am I from 0? That is what absolute value means. And I remember in elementary school doing these worksheets with like 50 absolute value problems, and I'm like, this is so stupid. They're not telling us what we ever use this for. It's just I always write the positive number. And actually finding an absolute value is easy, but now we're going to start using absolute value. And it starts with the meaning. Because of this, we never represent absolute value as a negative. It is never negative. Never negative. 0 can have an absolute value. The absolute value of 0 is the distance of 0 from 0. How far is 0 from 0?
Just 0.
0, because it's on top of itself. Yeah. All right, opposites. This is a special term, but it's under absolute value. Opposites are on opposite sides of 0, but have the same absolute value. So if I have a number line, get a nice straight line here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's say I have 4 and -4. All right, these have the same distance from 0. They're both 4 units away from 0, but they're on opposite sides of 0. One is in the negative direction, one is in the positive direction. Okay? And they have the same absolute value. The absolute value of -4, its distance from 0, is 4. The absolute value of +4, its distance from 0, absolute value of +4, is 4. So they have the same absolute value, but opposite signs. We're going in opposite directions. Okay? Which makes these a special type of pair of numbers that we call additive inverses. So opposites are additive inverses. These are opposites that add to 0. For example, 3 plus -3. This pair of numbers are additive inverses because they equal 0. There we go. -5 plus +5 are additive to 0. So what would be the additive inverse of 6?
6.
Oh, 6 plus 6 is 12.
Oh,
-6. The opposite -6. What would be the additive inverse of -10? +10. Okay, so those are some examples of additive inverses. All right, we're going to pause there for a moment. All right, for objective number 3, we're going to add integers using models. The first kind of model we're going to use is counter models. I recommend for written models that you do the following. Use minus signs for each negative integer that we are adding. And then I actually recommend using circles for each positive integer. And I'm going to show why in a moment. So when we are in example 1 adding 3 and 5, we're going to start by writing our 3 positives, 1, 2, 3. And then our 5 positives, 1, 2, 3, 4, 5. And we see that we have 3 plus 5 positives, which will be positive 8. Similarly, when we have 4 negatives, that's 1, 2, 3, 4 negatives, plus 2 negatives, 1, 2 negatives. These combined together, I have 4 negatives plus 2 negatives is 6 negatives, or negative 6. But when our signs are different, here I have 2 positives. I also have 5 negatives, and I can 1, 2, 3, 4, 5. And see that a positive and a negative, 2 of my negatives cancel out with my 2 positives. And I'm left with 3 remaining negatives. I could think of this as rewriting this 2 plus negative 2 plus negative 3, with negative 2 plus negative 3 being our negative 5. And then my positive 2 and my negative 2 cancel each other out, leaving me negative 3 remaining. Similarly, with this example, I start with 4 positives. 1, 2, 3, 4 positives. I have 1 negative, so one of these cancels out, and I have 3 positives left. Or I could look at this as taking my 4 and separating that into 3 plus 1, because 3 plus 1 equals 4, plus negative 1. And opposites combine, add to equal 0, leaving a 3 behind. So those are a couple different ways to look at adding integers using models. You might decide to list the numbers out separately and then cross them out this way as well, which is fine, which would show me that negative 4 plus positive 5 equals 1 positive. You can also add integers on number line models. Whenever we have a positive number, that means I'm going to start from 0, and this is my distance from 0, but in the positive direction. So I'm going to go from 0 in the positive direction by 1. For my second number, I'm going to start where I ended from the last one. I'm going to go in the positive or right direction 3 more. 1, 2, 3. Which leaves me at positive 4. So I see 1 plus 3 equals 4. In IXL, they'll show a line starting at 1 because this is a 1, and that's where we end up going first from 0. So just keep that in mind. Then in example 2, our first number is negative 2. So we want to be 2 away from 0 in the negative direction. We're going to go left 2. 1, 2. And then this negative 1 says I'm going to go in the left direction 1 more. So negative 2 plus negative 1 leaves me at negative 3. And we see here, because we moved in the same direction twice, our progress in that direction added to itself. It combined to make me go even further in that direction. In example 3, we start by going 3 from 0 in the negative direction. So this is where I start after my first number. Then I'm going to go 5 from this starting place in the positive direction. 1, 2, 3, 4, 5. Which leaves me at positive 2. And we see this canceling action happen again, where this positive 5 is being broken up into going 3 in the positive direction to get me back to 0, and then having 2 more positives left to end at our positive 2. We could also start going negative 3 from 0. 1, 2, 3. Going 3 in the negative direction. And then find that when we go in the positive direction, we don't cancel everything out. We only cancel some of it out. And we end at negative 2. In this case, I only canceled out part of my negative, 1 negative with the 1 positive, leaving 2 negatives remaining. So that is how we can add integers using models.